Okay, let's do it in English. Well, the idea of this is to, do you see all my screen, right?
Yeah.
Yes.
Yeah. Okay. The idea of this is to talk a little bit about Kafka, what Kafka is, and how can you use it. The title, what I tried to show you is that what Kafka is meant to be, and not what people start using it as a replace of a queue. So basically, starting with this, come on, okay. So starting with this, the first question we ask is Kafka a new queue, a new way of doing queue? For that, let's discuss what is a queue. A queue basically is a way of leaving a message so someone can take that message later, right? So basically, it's a postman. You give the card to a postman, he leave it in a mailbox, and someone pick it later from there. The idea is the same. It works in the same way, right? So basically, we can think of a queue as a postman. Something important to know is that once the message has been picked, the same happens with the letter. No one else can pick it up again because it was already picked. It's no longer there. So basically, what can we expect from a queue? Well, a queue, as we said before, sure us that the message has been read at least once and only by one person or one client, right? It follows the FIFO idea, first in, first out. This is not strictly true. Most of them have that configuration, but some products allowed us to change it to use a FILO or even the LILO idea. So we can change it in the configuration in some. The place where we leave the message, actually we're calling queues. You can see on all these tools, different tools that we have down here, that when you create one, they call this is the QA, this is the QB, this is the QC, and you connect to the queue, leave a message, and someone else connect to the queue and read it. Okay, you can have lots of queues inside the tool. Most of the queue use the act functionality. This is the acknowledge. It's basically when you read the message and you read it successfully, you let the queue know that that message has been read, so he doesn't share it with someone else again. If for any reason while you were reading it fails, the message get back to the queue and stay there so someone else can pick it later, or you can try to pick it again. Okay, some of the most populars are Amazon SQS, RabbitMQ, IBM MQ, ActiveMQ, and there are lots of more, but we cannot see that, all of them. Okay, so what is Kafka? Kafka doesn't follows the idea of publish and subscribe. So basically, someone publish a message and whoever that subscribed to you can receive the message. So basically, that's a radio broadcast, right? If someone in a studio broadcast the signal, and anyone at home that turn on a radio can hear what you are saying. You don't know if there is one person receiving your message, or 100, or 1,000,000, or no one. You really don't care about that. You're just broadcasting the idea. So Kafka works this way. Okay, so following that idea, let's think together if Kafka can be a queue or can work as a queue. So the first thing is someone sending a message. Yeah, a queue receive send a message. Someone has is sending a message. On Kafka, someone is sending a message. Is someone receiving a message? Yeah, on the queue is someone receiving a message. On Kafka is also someone receiving a message. Follow the FIFO idea. Yeah, on both Kafka and a queue follows the FIFO idea. The first message in is the first message out. Yeah. This is not exactly correct in Kafka, but in general it works this way. We will see later why it's not so perfect that. Kafka calls topic what we call queues on the queue. Each topic is the place where we put the message. So basically it works in the same way, or at least we can think about that in a first approach. So as a first approach, we can say, yeah, Kafka can work as a queue. So since everything that you do on a queue, it looks as if we can do it on Kafka. Okay, let's try any example. Oh, sorry. Is there any question? I feel as I'm going too fast. Feel free to ask if you have any question. No? Okay, let's continue. Well, this is an example. This is basically a standard sales application where the user, where a client makes, or the salesman make a sale, receive a sale. So the sales application put a message on the queue so the product team can get that message and process it. Once it's processed, it put it on the delivery queue so delivery can take it and deliver the product. Also put it on the invoice queue so the invoice can make actually the invoice for that product so we get the money back, and send it to account and put it on an invoice queue that later accountman can say, we'll sell this for this money. This is the order and this is the invoice. That the order came from the sale on another queue, and finally the invoice put it on the product invoice queue, so delivery has the product, the invoice, and can send it back to the client, right? This is a standard application. It's true, in general, you don't use queues for this, but if you need it to work in an asynchronous way, this is the most popular solution. And now with Kafka, it's basically the same, but instead of using queues, we're using topics. But we can do exactly the same that before. It follows the same idea. It works. Trust me, if we do it in Kafka, it works fine. It doesn't have any problem. But seeing this, we can say that Kafka can work as a queue because at the end of the day, everything works fine. But Kafka was not thought to do work this way. So let's try again. And this is more a Kafka idea. The main difference here, you will see that sales only send one message to the sales topic, and everyone received from sales topic the message accounting, product. Then later we're going to see these two that are on orange. The product also put a message on topic that invoice and delivery receive it. And invoice puts a message on invoice topic that accounting and delivery receive it. You will see that more or less are the same number of lines, but the difference is that we have the topic. The good here that the orange, it thinks that we can add to the flow without changing nothing that is working today, right? Since we can read, anyone can read from the sales topic, we can have more than one reading. I can, for example, say, I want to get a module in my product from sales statistics to know which is the salesman that is doing more sales. So I read the sales topic, and I know I can know who is the one that is selling more, how many sales I have today, how many sales I have last week, and lot of things of statistics. That in the previous idea with queue, I will need someone to put a message in the queue so I can read it. This way, it's just reading the same topic that everyone else is reading. And also, we can have an operation tracking. Let's say we can say that there exists a sale. That sale is related with the product that I put wrong the number name here on the product topic that appears, and I have the invoice from that sale. Everything here at very low cost because the methods are already there. So keeping this in mind, let's see a little bit of things that have changed. Okay, the fourth thing that we can see here in this diagram, difference with this one, is that we have less queues or topics. We have only 3, when in the first one we have like 2, 4, 6, right? Twice the number of topics. And if we add things, we will have more. The second thing is that the diagram is a little bit simple because since we have less things, it's simple to follow. The most important thing that I think that is add here is that we can add things without too much work, because since we already have the message and anyone can pick from there, you can get that information and do something that you were not doing before, right? That message can receive it on another place and things and do things that in the past you were not allowed, or it was too expensive to spend the money on that, because probably, I don't know, if this was done in a traditional way, the sales statistics, I won't do it because it's just to know and it doesn't give me a huge benefit, and I don't want to spend money on this. This way is just creating the model and connected to an existing flow that doesn't change. Okay, so basically adding things is the main benefit that at least I, in my experience, see using Kafka. We can get the same info and the flow doesn't change. And all this is because of the idea of the events. Kafka strongly suggests the idea of using an event-driven architect, not the traditional architect. But it's not something that is required to use in Kafka. It's something that they suggest to use, works great with Kafka, but if you don't like it, if you still want to use it as you used to do, Kafka works. For example, as we do here, Kafka works with this. It's not incredible or difficult to see. Actually, I see it in some places, but it's not the idea of Kafka. Okay, so what are the differences between a queue and a public and subscribe? The main difference, or one of the first difference that I see, is that in a queue you send a message. You are requesting something, you are asking for something or sending something to someone. And in the public and subscribe, the idea is more like you notify something about something. You are not requesting something. For example, I don't know, the sales, if in the queue you will say, I have a sales, I have to create a sale. In the public and subscribe, the idea, or in an event-driven idea, you say, I create this sale, and someone pick that, start an action because of that. Let's say in the first one, it's more, you ask someone to do something. In the second one, that someone start the action because something happens. That's the main difference in the way of thinking and in the way that events work, right? Events are things that happens, are not actions made a request by someone. But well, I don't want to get too much inside what events is. Okay. So as I tell you, queues do request, Kafka notify. It at first it looks as a small detail, but it's a huge difference. Well, queues allow the ACK method. Kafka doesn't by default. Of course, you can change it in the configuration. Kafka doesn't use it because Kafka cares most about performance and doing things in high scale. Actually, by default, Kafka what's called said that send the message at least once. It guarantees you that the message you're going to receive the message. It doesn't guarantee that the message will be only sent once, but yeah, will be sent. In the queue, you can have a more strict relation with the ACK. If, of course, you need to handle it correctly, but with the ACK, you can be sure that the message was only sent once and all the messages were sent. With this appears the idea of idempotent, where the message you need to realize on your application that the message was originally sent and all that is the same message that you received before. On configuration, Kafka allows you to change all this. The problem with that is that you lost a lot of performance from Kafka, and in most cases, it's not recommended. It's better to do it on your side that I'll ask Kafka to change them. Well, this is basically the Kafka producer doesn't care about if someone gets notified, it just notifies. Everyone else know what to do. So things like an error topic or a reply topic that in queues is more common. It's very common to have, I don't know, if I send to an external application something on a queue, I have a reply queue and an error queue to get the response and get the error in case something fails. In the event or Kafka ideas, you just notify that thing happens, and if you need a reply from the external service, the external server will notify you. He won't tell you this is the response. He will tell you, I create this or I do this. Okay, and the last that we talk about, Kafka topics are meant to be receive the message by many, and queue is only by one. Of course, a lot can read from a queue, yeah, but only one will get the message. Okay. Now let's talk a little bit about Kafka. What is Kafka? As we said before, sorry, any question before getting further in this? Great, or you're asleep, or
I have one. I have a question.
Okay.
So, yeah, the orange square that you share, it says sales statistics, something like that, right?
Yeah, this one's.
Operation tracking, there you go. So it means that this orange guy was subscribed to 3 different topics, right, at the same time.
Yeah, you can subscribe at any number of. Imagine of this is a microservice, right? Basically, so you can subscribe to any number of topics. As the same way you can subscribe to any number of queues. The good thing here is the.
I was going to say the microservice logic, so you answer already. It's something like that, right? This microservice.
Yeah. The idea of this, let's say, I don't use the word microservices because it's not strictly related with that. This can be different models inside a big application, but really, if you're going to do it this way, it's better to use microservices.
Okay, thank you.
No problem.
And I have
Okay,
one more question related to the orange boxes. So
yeah,
this will be like workers in the microservice that are listening or are subscribed to the Kafka events. I mean, these are processes within the microservices that run continuously, listening for or waiting for messages in the topics.
Yeah, every time you subscribe is like you are listening. You are, yeah, I don't know exactly how the library works, but you are connected to the topic, and when the message gets to the topic, you receive it.
And that is a process that runs in the operating system, keeps running.
Yeah, yeah. Yeah, it's running in the operation system, yeah. Yeah, it's like it's more like the UI that asks to the server all the time, instead of the server notifying you. You subscribe to allow the access, but then it's like you are the one asking for the new message all the time. Actually, if for any reason you get down, and let's say if you connect in a new with a new group ID, that's the way that you handle this. We will see it later. To a topic, you will receive the message from that moment farther, right? You won't receive the message that happened before. You can change that in the configuration. This is you can do lots of configuration, but most of the people, or at least in my experience, use default, and that's not the way that you don't want. You don't want to have the message from 3 years in the past. Well, at least I don't think you will save so much information, but you don't want to have the message of yesterday if you are starting today, right?
Right.
It's normally is from now on.
Right.
But yeah, there is no limit in the number of things you can add to the topics. That's the good of this, that you say, oh, it will be good to have, I don't know, a sale invoice relationship, and you put a new microservices that range from the sale topic and the invoice topic, and you do whatever you want there. That's the first benefit of doing things like this. And also something that I don't put here, or I put it in not a so direct way, is that since all these are events, you can track the events. You can say, well, I have an event here that is related with the event in the product that is related with the event on the topic. So I can do some traceability. Actually, in the past, I create a model that do all the traceability of all the events that we were sending. That way, when you can find where the event get corrupt or receive information that we don't want, right? Because, for example, I don't know, when this finished, you find that the invoice is for too little money. And doing that track, you can find that the sale guy put wrong, instead of the dot, put a comma, and the number get corrupt in a different way. And that was the issue. But it's difficult to find in all the systems, because it's something that don't fails when it was done. It fails later at the end when the number doesn't match. But well, that's are just a use case that you can add. The good of this is that the original flow not even know about these new things. It's still working as it was before. In a more traditional way, let's say with calling a URL or something like that, you need to modify the sales, for example, to connect to the new one, to send information somehow, put it on a doc, put it on someplace so he can get it. This way, the original flow is still working perfect. It doesn't change anything. Actually, you don't know that have changed. Actually, I think it was in Matias project that we have a flow with we had a publish and subscribe tool, and they start getting metrics, and we get notified of that like 2 months later they start, because it doesn't affect us, but they were reading from our queues. Well, let's continue. Well, what is Kafka? Let's talk a little bit about Kafka. Kafka works with topics. They call topics the place where you put things there. All topics can be consumed by any number of consumers, by subscribers. Sorry. Kafka is very easy to cluster it. I don't remember at this point, but in the configuration appears the options, or on the configuration file already appears how to cluster it. It's just starting to and say which is the IP of the other one. It's really, really very simple. It follows the FIFO idea. Okay, let me summarize this. Do you remember that we were talking before that it follows the FIFO idea, that it guarantees that the first in is the first out? Well, that's not always the idea. When you start using the retry, it happens that Kafka use parallel things, so it improves his performance. When you try to improve doing things in parallel, what happens is you use 5 methods, and one method fails, the other 4 correct. If the first method fails, it gets requeued. So the 4 others get processed before the first one. So you lost the order in that place. You can change that, as you can see at the last line. You can change it with each configuration saying 2-1, but you lost all that performance of sending 5 messages at the same time. So it's better to see if you care really about the order. How are you going to handle it? If maybe it's better to receive the message and then processes. It depends on you. But it's good to know. By default, Kafka doesn't do retry. But since the functionality exists, it happened this, and the idea of FIFO get break. Other thing important about the topics is the partitions. Partitions is like the heart of Kafka. Partitions, what says is that if I have 2 consumers and I send a message, both consumers receive the message exactly at the same time. If I have only one partition, when I send the message, first one receive one consumer and then the other. This doesn't look as a big deal, but when you start to use millions of requests or message sent, as we have been with Emiliano fighting with that, these things start to care, because receiving, let's say, in 2 time slots, you can receive 2 or 4 messages. That's only with 2 partitions. If you have 10 partitions, it gets to receiving 2 messages and getting 20. What is the drawback of this? The topic, each partition has to be to a different consumer. You cannot have 3 consumers and 4 partitions. We're still receiving only 3 messages at a time, because the 4 consumer partition is free, and actually you are wasting, because Kafka is, when receive a message, it's putting it in 4 different queues, and you are like wasting resources. Let me show this on this message. On this message, you have a standard Kafka cluster, has 4 partitions, and have 2 consumers. That consumers work in group, right? You can have 2 consumers that receive from the same partition or the same topic, and they split the message that they receive. That's why the groups work hard. The idea of this is that you don't receive the same message on two groups, and you can handle things in different way. For example, in the past, we were reading messages from Twitter that received millions of messages, and we don't care. We just, let's say, we get the message from Twitter, we analyze if it was a valid one for us in different threads, in different microservices. Actually, we have like 10 microservices, and we put it on another place to process later. But from 1 million, we only care about a few hundreds. So with this way, we were able to get it out. And everyone was on the same group, so none of these microservices received the same topic on the same message that already was received by another one. So you can see here what I was saying is that each partition go to a different topic. If, for example, in this case that we have 4 partitions and the group A only have 2 customers, 2 partitions go to the same customer. Kafka try to put both of the same server in the same consumer, but it depends of how you connect there is not so exactly. But basically, if you, as I say here, you are not earning more speed because of this, because you cannot consume 2 messages at a time with 1 consumer. Actually, this for me is a waste of time. But in consumer B that you have 4 consumers, you can see that each consumer go to a different partition. A message in partition O cannot be to consumer 4, never. It will always be done by consumer 3. So if by any reason consumer O gets delay, only the consumer 3 will be affected. The other ones will still working correctly. Okay, any question about this? Sorry. Do you understand the partition part is really, really important for Kafka when you are talking about performance? It's one of the most important features that Kafka has related with performance. Okay, so let's stop sharing this. Let me share something else so we can start seeing how Kafka works. Okay, so 1 second. Let's share the desktop. Okay, do you see my console? Sorry.
Okay.
Yes.
Yes.
Okay. Let's.
It looks like a Tetris.
Yeah. Now, what I'm going to do now is I have my here. Okay, here let's do this. Here is the producer, right? Now let's create 3 consumers. First, we will create a consumer. Let's clear the buffer to make it clean. And the other 2. Okay, what is, well, Okay, what do we have here? We have the first one on the left is just a consumer with a group ID. The second one and the third, the middle one and the one on the right, use the same group ID. So if I put a message here, you will see it appears only on two of this. The one in the middle doesn't appear because it was already sent to the one on the right. And since they use the same group ID, it's only received by one. This is an example. Another example. Okay, so you can say now, well, the one in the middle is not doing anything. So let's shut down this one and send a last example. And you will see that, oh, okay. Since the other one wasn't there anymore, Kafka sent it to the other one that was connected with the same group ID, right? So basically, this is the way that Kafka works. You can create a number of consumers that you want. There is not too much to say here. I don't know if you want to ask something or see something else.
I have one question regarding the consumer groups. So are they meant to have something like high availability or to scale up a group of consumers in case you have many messages and one single consumer cannot process them all, or is for something?
Yeah. No, that's basically the idea of this. Basically, if you see here, I don't know if you can see it correctly. I'm setting the group ID and I'm getting it here. If this connect and I add a new message, well, it tries to send it to the group to the first one available, and the last uses the first available. Of course, I am not able to send so many messages that it decides to send it to the other one. But for example, you can increase this as much as you want, and you can read from the same topic with multiple consumers of the same group, so you can read the topic faster, let's say. Because sending a message, maybe you can receive like 2 million messages an hour, but you can process only, I don't know, 100,000. So the only way to solve that is adding 10 microservices this way, so you can meet what you are meant to be in real time, right?
So when a consumer
that's basically the idea.
When a consumer is processing a message, is blocked, right? It won't be able to process another message, and then that will go to the second consumer in that consumer group.
Yeah. Yeah, it's really fast, the consume, because it's just reading the message. It doesn't have an out or something like that, at least not by default. It's not that you can make it wait. But it takes some time because, probably this is a JSON, it has a transformation and things like that take some time. And when we're talking about millions of messages in an hour, you need to be really fast. So this way you can increase the number of machines to read from a queue.
Makes sense.
It's just in case you need. And of course, the other one that is not in that group still read the queue at the standard speed. It's independent of the ones inside the group, and you can have as many groups as you want. Basically, this is if you have a microservices in a cluster, that cluster, all the instance of that cluster has the same group ID. That's basically the idea of this. So when you increase the number of instances, they still read from the same topic as one. If not, you will start to have duplicate information.
Makes sense. Thanks.
But well, That's basically the.
Do you know,
example
Mati, if
here.
it can be used by like a WebSocket?
I know that older versions has a way to do it as a socket. I don't know the new ones. Really, I don't know. But probably you will need to use another tool for that, because as in my experience, it's not a good idea to do it that way. But yeah, like 4 or 5 years ago, when I started with this, the first thing I did is I connected.
Cool.
Okay, so let's finish with the presentation. Okay, so let's do this. Okay, so final comments. There are many parallel supply tools. Most commons are Kafka and AWS SNS, but there are lots of more. Partition, as I said, is very important when you are talking about performance, because as I tell you, it is the speed that consumers consume the message, and when you are trying to care about performance, that is important because of the scalability you can give them. Ideally, you will have one partition per consumer. Taking care here that says per consumer, not per consumer group, right? If you have two consumers in the same group, you're still having two partitions essentially. Well, if you have, I'm not quite sure about this, but if you have 3 partitions and 2 consumers, I don't know if the third consumers go to the first partition or stay idle. It depends on what version you are using. If it's stay idle, you are wasting resources because the messages are being set there and are not being handled. And if not, if it is consumed by the first one, you are still replicating the message in 3. That one is not needed. Okay, so also changing the mindset to events is great. It doesn't fill all situations. We cannot use events for everything. But in many situations, like for example, the one I show you, events is a great solution. It works great and it simplifies a lot of things. And tracking events to get the traceability is great. And of course, this is great if we can add models in a very low cost. Okay, well, that's all. No, joking. Any questions? Any other question? No?
No, from my side.
No, I'm good. Thank you.
Okay, well, thanks for listening to me.
Thanks a lot.
That's all.
Great talk.
Thank you,
Matias. Great talk.
Bye.
Thanks, guys. See you later.
Yeah.
Thank you, Matias.
Thank you. Bye-bye.